Global variables are a little trickier. Their primary benefit is in allowing multiple functions direct access to the same variable. But this too is their primary failing. Nevertheless, there is a way to use them safely, so let's take a look. Rather than having the local apples variable in the main function, I'm going to add functions to get and set this value and use a global variable for storage. Apples set, and apples get. So we now have a global variable called data. This variable represents the shared storage for the two functions that get and set the apples value. Now if we update the main function to print the value of apples using this get function, we'll notice something different. Again, we'll compile and run to see what happens. And sure enough, the program prints 0, even though we never initialized the apples global variable. The global variable is initialized to 0 before the program's main function is called. Of course, the main function can still access the data variable directly. We could hide it by placing the apple-related functions in a separate source file. We now just need to update the program.c source file to include the declarations of the Apple-related functions, and the implementation is hidden from the compiler. I can now call the set function to indirectly write to the global variable, and the get function to read its value. So far, so good. If I go ahead and compile and save, and then run it, I can see the expected value. Remember now that there is more than one source file, so I'd better name the resulting executable. But now, what if I needed to add another library to handle oranges? I can add similar functions to support oranges. Oranges set, oranges get. Great, now I can use apples and oranges together, right? Let's give it a try. Apples set to 5 and oranges set to 10. Let's print them both out so we can see. Oranges %d and oranges get. Now if I go and compile and run this, we might be in for a little surprise. fe program.exe to give it a name. Now we see apples equals 10 and oranges equals 10. As you can see, setting the oranges somehow also overwrote the apples value. This is another one of those differences between C and C++, which can get you into trouble if you're not careful. Using the C++ compiler to check the code helps to pinpoint the problem. You see, in C, a global variable is just a declaration unless it's initialized. In contrast, C++ assumes there are definitions and warns about the duplication. So one way to solve the problem is to always initialize global variables. That way the C compiler will pick up the duplicate variable name and warn you about it. But this is risky because you might forget to initialize one. Another option is to use different names, but that can become problematic as the program gets larger and more programmers work on it. Fortunately, C provides a solution to this problem, and one that works just as well in C++, and that is to use static global variables. Again, a static variable is privately declared and defined for the exclusive use of the functions in a particular source file. If I prefix each global variable with static, they will no longer collide, and the C compiler will provide distinct storage for each variable. Let's give it a try. Compiling and running produces the results we expected, distinct values for apples and oranges.